All right, we're now going to use the properties of logarithms to write each expression as one logarithm. Don't mind if I do. So in part A, when you are adding logarithms, you multiply the arguments. So this will be log base 6 of 12 times 3. 12 times 3 is 36. But now pay attention because sometimes these simplify even further. 36 is a power of 6. 6 to what power is 36? 2. So this one happened to simplify to 2. They don't always simplify, but you should always check. So again, when you add logarithms, you multiply the arguments. In part B, we are subtracting logarithms. So what do you think we do to the arguments? Yes, you in the back row, you divide the arguments. So the new argument is 24/3, which reduces down to 8. 8 is a multiple of 4, but it is not a power of 4, at least not a nice power. So log base 4 of 8 does not simplify any further. Leave it alone. In part C, unlike parts A and B, we have coefficients that aren't 1. If you have a coefficient that's not 1, you can bring it up as an exponent to the argument. As a word of advice, if the coefficient is negative, don't take the negative, just take the, what follows the subtraction, I should say. So we're going to move the 2, the 3, and the 5 up as exponents to the arguments. So the first one now becomes the natural log of x squared plus the natural log of y cubed, and then minus the natural log of z to the 5th. So now this problem is a combination of parts A and B. Since the first two logarithms we're adding, what do we do to the arguments? Hopefully you said multiplying. And now we are left with two logarithms that we are subtracting. If you are subtracting logarithms, what do you do to the arguments? Hopefully you said divide. So our final answer is the natural log of x squared y cubed over z to the 5th.